Okay, welcome to Unit 4, Lesson 1. We are talking about area measurement. So Lesson 1 is all about two-dimensional area review. So area is the number of squares that it takes to cover an area or region. Okay, so it is two-dimensional. And surface area would be the three-dimensional. It says determine the area of each square. So to determine the area of each square, you literally just count the number of squares. Okay, so we got 9 units squared on the first diagram, 16 units squared on the second diagram, and the third diagram is going to be 5 by 5 length and width. So if I go 5 times 5 to get area, I'm going to get 25 units squared. So like we said, area is two-dimensional, so your area is always squared. Volume is three-dimensional, so it'll be cubed. Now, typically we mostly think of area as length times width. If it's a square, however, the numbers are identical, just like we saw there, 4 and 4, 5 and 5, 3 and 3. So when the numbers are identical, you just have to do side squared. So it becomes side times side, which you could say is n times n, which we say is n squared. So you're literally just taking the side and multiplying it by itself. So on this one, I would go 9 times 9. That's going to give me 81. And now you put your units. So I've got millimeters squared. Okay, 9 times 9, I get millimeters squared. If it's a rectangle, again, you'll take your length times width. Now, what do these little dashes here mean? Those are telling us that all of the sides are identical. Whichever ones have those identical dashes will be that same size. So this is telling us it's a square, a 7.2 times 7.2, and that's how we get our area for that one. And we're going to get 51.84 centimeters squared. So on these ones, it does matter when you put your units, because I will be looking for the squared part on your unit. So this part now does matter, okay? Whereas before, I didn't really care if you put your units. Now it's going to be important to include your units every time. All right, turn your page here. What if we take areas of rectangles now? So we took areas of squares where the sides are the same. Area of rectangles, as a review for us, area is length times width. So we would take our length and our width, and we would find the dimensions. Here I've got 5 squares. Here I've got 3 squares. I would take 5 times 3, and I'm going to get 15. So my answer is 15u squared. You always put a u if they indicate no units. So you're indicating units by putting the letter u. Okay, units squared. On the next one, I've got 4 on the bottom, and I've got 7 going up and down. So 7 times 4 is my area, and that's going to give me 28 units squared. Now we're going to look at some more challenging ones. All they've done is they've made the numbers over 10, and they've also added some decimals in there. That's what makes them a little bit more challenging, is they've got decimal numbers in there. So example 2, we've got 8 times 17. That's going to give us 136, and again, using our units, centimeters squared. On the next one, we need to take our length times our width. So we're going to take our 10.3 times 4.5. Your calculator will do it. And if the question doesn't tell you how to round to 2 decimal places. Okay? One is okay, 2 is more accurate. So on this one, we're going to get 46.35. And this one is in also centimeters squared. The next object we look at is a parallelogram. And a parallelogram is roughly a rectangle that has been pushed over. So instead of 90 degrees on the sides, they now have angles. Okay, so those are parallelograms. Now, whenever we deal with finding area or even volume, we deal with what's called the height. You never deal with diagonal lines. So what we do is we find the vertical height in these. So this is super important for us to find, is always that vertical height. We're going to make a little note. We never use diagonal lines. We never use diagonal lines for area. You will use them for perimeter, but you'll never use them for area. All right, so for the parallelogram, what they're showing you here is they've cut this piece off and they've just put it on the front. And what it does is it takes your parallelogram and really creates just a rectangle, okay, if you cut that one triangle off. So that's why we deal with the height of parallelograms. So for area of a parallelogram, we deal with base times height. That's all, just base times height. And if we take a look at this one, there's supposed to be a grid there, but you guys can't see it. It looks like this, and it goes down like this and over, okay? And it's got A as the height. A as the height is 5. So A is 5 for the height. Now the length, that's going to be this line right here, okay? That's your base. So your base or your length, that is going to be, what did we say here? It's going to be 8. Okay, so that's going to be 8. It should be showing a grid there, but the grid didn't photocopy very well. So you have to draw that diagram. So that's going to be an 8 by 5. So the area for this is just going to be 8 times 5. We're going to get 40 units squared. On the next one on the right, area 6 times 4. That's going to give us 24 units squared. Now on these questions, they're going to show us the diagonal lines. On the next two, the only thing that makes them more challenging is they're giving us the value of those diagonal lines. They're not saying, here's 2 numbers, use them and multiply. So if you're doing your homework and you've got questions like this, and you do have to show me at least one step, this is good enough. All you have to do is 4 times 6. That's good enough to show me your work, okay? Because that tells me you understand to multiply those, okay? So if you take a look at C, the only thing that makes that more challenging is they put one of the diagonal lines. So all we're going to do on that question is cross off the diagonal. We're not using the diagonals ever, okay, unless you're doing perimeter. That's one dimension. So area for this one is going to be 8, the base, times 4.3, the height. So area on this one is 34.4. And we're going to use our units, 34.4 kilometers squared. Okay, 34.4 kilometers squared. The next question. Again, if there's lots of numbers on there, the first thing we do is cross off diagonal lines. Diagonal line, I don't need to use it. Okay? If I had a lot of diagonal line numbers on there, I wouldn't be using them. All we need is the base and the height. Well, on this one, they have it standing sideways. They don't have it laying nicely on its side. So these ones can look different, but all you're still doing is multiplying those 2 numbers. So you're taking those 2 numbers and multiplying them. That's all you're doing. So 5.5 times 6.1. And that's going to give us 33.55. And that's meters squared. Now, if we take a look at area of a triangle is half of a parallelogram or half of a rectangle. So if you have half of a parallelogram or half of a rectangle, it's going to take your base times height or length and width, and you divide it in 2. Why do we divide it in 2? Because you cut them in half. If I've got a rectangle, I cut it in half, I've got 2 triangles. So since I'm cutting it in half, I would take half of its area to get the area of part of it. So that's what the area of a triangle is. So area of any triangle is going to be the base number times the height number, all divided by 2, because you're cutting it in half. It's not that entire object. It's just a triangle. And again, what we're going to get used to doing is crossing off the diagonal lines. We're only using base and height. We're not using diagonal lines. So again, we put a little hint, no diagonal lines. Lines for area. We use them for perimeter, but not for area. That does not look like the word lines. So no diagonal lines. We will cross those off. So on the next one, again, it's supposed to show you in a grid, in a diagram. So I'm going to give you the numbers. This is going to show us a 5 for a base, and it's going to have a vertical height here of 4. That's what that one's showing us, is a base of 5 and a height of 4. So the area for this triangle is going to be 4 times 5 divided by 2. Well, that's 20 divided 2 is 10. So we're going to get 10 units squared. Okay. The next one, this one you've got to make the right angle outside the object, and that's okay. You can do that. You can make those outside the object. So my base then becomes 5, and this here should show you 3. They're showing diagonal lines on here. And the one diagonal line here is a 9, and then this guy here is a 4. We're not using those numbers, okay? The numbers we're using are the vertical and the horizontal. So area for this one is going to be 5 times 3, all divided by 2. So 15 divided by 2 to give us 7.5 units squared. Okay, 7.5 units squared. Turn your page. We're almost done this one. So again, on these triangles, the first thing you do with any triangle, we are going to cross off the diagonal lines. We never use the diagonal lines. We only use the base and the height, never the diagonals. So this one, I'm going to take 6 times 10, divide 2. On this one, 5 times 5, divide 2. And then I'm done. So 6 times 10 is 60, divide 2. That gives you 30 meters squared. On the right, letter D, 5 times 5 is 25. Cut it in half. We get 12.5 inches squared. Now, inches squared, they write it like this. SQ for squared, and then IN for inch. So they would write it as squared inch or squared foot, squared mile, squared yard. That's how they would write it. Okay? Both are correct. The one that is more proper is that one. Okay? So if you understand that the SQ means squared, that squared sign, that's all you do. You just kind of write them in reverse order. All right. Example 5 is going to have a whole bunch of it. We have to do the equation that matches the object. So when I take a look at this object, I count 6 here, 5 here. It's a rectangle. So area is 6 times 5. I get 30. So my area is 30 units squared. U squared. The next one, whenever you've got a 90-degree angle, the base and height are always attached to the 90. Remember, you're never using a diagonal line. So this guy's a 6, this guy's a 4. Area of our triangle says multiply them, then divide by 2. That's going to give me 12 units squared. Okay, now we're going to work on B and E. B is a parallelogram. It doesn't have any numbers on the diagonal, so I don't have to worry about that. All I'm doing is length times width, or what we call base times height. So 20 times 15, that's going to give us 300 centimeters squared. So make sure you're writing this down so you've got it written down in your notes. because when it's open book time, you're going to want to have this written down. Okay, on the next triangle, what makes it harder? They gave us all the diagonal lines. So we have to cross off the diagonal lines. We don't use them. Okay, so then now we're going to take the base times the height, because we have a triangle. We took all of those diagonal lines and we got rid of them. So we multiply base times height, and then we got to divide it by 2 because it's a triangle. So base times height, divide 2. Okay, base times height, divide 2, because it's a triangle. So 8.5 times 4, and then divide it in 2, cut it in half. Well, that's going to give us my favorite number, 17 centimeters squared. Letter C and F. So C and F, again, we crossed off the diagonal lines. We use base times height. It's not a triangle, so we don't divide by 2. We just take base times height. So 0.7 times 1.8, that's going to give us 1.26 meters squared. The next one, again, area of a triangle, base 2.2 times 2.8, the height, and then divide it by 2. And that's going to give us an answer of 3.08. 3.08 meters squared. All right. When you got that written down, turn your page. Okay, turn your page. Example 6, it's talking about estimating area of your circle in squares. So when they give you a square grid like this, what you do is you calculate how many squares it takes to go all the way across. So I've got one, let me grab my pen here. I've got through the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the diameter is 10. For circles, we take the radius and square it times pi. So now I need radius. The radius is diameter divided by 2. So my radius would be 5. So since my radius is 5 units, area of a circle is radius squared times pi. That's how we have to put it in our calculator. You'll see it on formula sheets as pi r squared, but in the calculator, you got to put the r squared in first. So in our calculators, if we were to estimate this, basically, how big is pi? About 3.14, right? So it's about 3. If I were to say, take 5 and square it, that means 5 times 5. What does that give you?
25.
Exactly. What's 25 times 3 roughly? 75. So it should be around 75 units squared. Now we're actually going to find out what it is. So that little squiggly line before the answer, that means around or about or approximately. Okay. Now we're finding the actual area. So we're going to go r squared times pi. So 5 squared times pi. That's going to give me 78.5, yada, yada, yada. And that's going to round only to 78.5. So we've got 78.5 units squared. Our estimate was very close. So if this is a multiple choice question and they say estimate, but they don't have decimal answers, that means you pick the one that's closest. That's all that means, okay, is you would pick the one that's closest. All right, so now we're going to be using the formula pi r squared. So again, you're going to see that formula written that way. But in the calculator, we must put it in as r squared, then times pi equals or enter. That's how we have to put it in the calculator. So it wants to the nearest tenth for to be rounded. So that means you want to see one number after the decimal place. That's what that's telling us. So on the first question, that's my radius. I'm going to go 4 squared times pi. So 16 times pi. And that's going to give me 50.26, yada, 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 which is going to give me 50.3 square inches. Or you could put inches squared, whichever you prefer. Okay, so 50.3. Okay, you should be writing these down. How come? Because you're going to have open book time on quizzes and tests, and you want this stuff available. All right, second thing on your area for the second one. Again, you identify, is the line they show you, is that a radius or is it a diameter? Halfway across is radius. That's the number we want. So we're going to take 7 squared times pi, and we are going to get 153.8 something, 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 and the number after the 8 is going to round it to a 9. So we get 153.9, and that's centimeters squared. Make sure you're adding your units, please. On the next two, they don't give us a radius, they give us diameter. So we have to find radius by taking diameter divided by 2. So 10 divided by 2 means my radius is 5. So that means I can take now my 5 squared times pi. That's my area of my circle, because I want to go pi times my radius squared. And again, in the calculator, you got to stick the number squared first. So 5 squared times pi. And that's going to give us 78.5. And that's centimeters squared. Okay, looking at the second one there. Again, that's a diameter. So radius is going to be 3 divided 2, which is 1.5. So area of our circle is going to be our radius, 1.5 squared times pi. That's how we're typing it in our calculator. And that's going to give me 7.1. It rounds to 7.1. And that's meters squared. 7.1 meters squared. Okay, last couple examples. When they don't draw a diagram for you, sometimes it's good to draw the diagram so that you're not confused about the information that they give you. So on the next couple pieces of information, they only tell us in words. We're going to have to draw the diagram so that we understand what's going on. Okay, so when you're ready, turn your page. Example 9 says we have a radius of 7.3. So if you're not sure what that is, you can draw a diagram. Radius is 7.3. So my area of my circle is going to be 7.3 squared times pi. You have to hit that little squared button. It won't work if you don't. So 7.3 squared and then times pi. That's going to give us 167.4 centimeters squared. On the next one, letter C, they're giving us diameter all the way across is 8.6. So radius is half of that. 8.6 divided 2. So our radius is 4.3. So area of this circle is going to give us our 4.3 squared times pi. So 4.3 squared times pi. And that's going to give us 58.1. So we get 58.1 centimeters squared. Okay, last two on example 9. Again, they tell us they ask us to find area, they give us radius, and the second one gives us diameter. So this time I'm not going to draw the diagram, I'm just going to do the work. So again, area is, for a circle, radius squared times pi. I write it that way because that's how you have to type it in the calculator. So we're going to get 20.5 squared times pi. And that's how you type it in. And that's going to give us 1320.3. So 1320.3 centimeters squared. Okay, the next one says diameter, and we have to divide that guy by 2 because we want radius. So radius is going to be 18.2. So now I'm going to say area of my circle is 18.2 squared times pi. So 18.2 squared times pi. And that's a big number. 10,040.6. Whoa, 1,040. Where'd I get the 10,000? 1,040.6 centimeters squared. Our last two examples. One is a circular rink and one is a circular spray pattern from a circular sprinkler that goes round and round. You know those ones that go that's what these sprinklers are about. So it says it sprays a distance of 8.4. So if I'm the sprinkler and I'm going 8.4 all around and I'm the middle of the circle, what does that mean? What part is 8.4? Is that all the way across or is that only halfway? Well, let's think about it. There's my lawn. I'm going to put my sprinkler in the middle of it. Okay, my sprinkler's in the middle of it. And now it's got a spray. So if I've got a spray pattern on it, it's going to be my radius. The radius is the spray pattern going around it, especially when you start in the middle. So that means it's 8.4 meters as its radius. So now I know area of my circle is going to be 8.4 squared times pi. And that's going to give us 221.7. So I get 221.7 meters squared. Don't forget your units. Okay, last one. This one is telling us we have a circular rink, but we have a diameter. Diameter's all the way across is 25.8 meters. I need to cut that in half to find the radius. So radius is 25.8 divide 2. So my radius is 12.9. So now my area of my circle is my radius, 12.9 squared times pi. So 12.9 squared times pi. That's how you have to type it in. And that's going to give us 522.8 meters squared. This concludes basic area of two-dimensional shapes.